I don't know.
Okay, no idea. Most likely mid-December or something like that. Okay, so what have you been doing?
Absolutely nothing.
School? At home? Or
Absolutely nothing.
yeah, but are you having school, or you are
Yeah.
on holiday, or okay, never mind. Okay. May I know if you are using your iPad or you are using your MacBook to
Computer.
computer? Okay, good. So I have sent you the PDF asking you a few questions. So anything to share with me from your side?
Can you help me go through the topics that was not tested in PSLE for P6?
Oh, that one I will go through in the later chapters. So let me share with you what is my plan. So you have a better overview what you are going to learn, and then let me see. Can you see my screen?
Yeah.
Good. You see, then one syllabus. Fine. So let me just do it. See. Yeah. All right. So when you go to secondary school, and this will be the syllabus. So let's take a look at one of them. Your Sec 1, right? So yeah, over here. Okay, so the first chapter is actually numbers and operations. So the chapters that you are not tested during your PSLE, but you still need to learn is over here. Over here. All right.
Okay.
Can you see over here? You have the speed, okay, and then you have the average speed. So this is about distance. And then of course you also have the problems involving the rate and speed. Rate means like the volume, the tap, like the water going in, then the water going out, that kind of stuff. Okay, so that will be N4, rate and speed. So this will be chapter 4 of next year, your Sec 1 syllabus. So I will do this syllabus, I will do this topic while you are learning next year. So today, what I will focus on today is over here, the first chapter over here. Numbers and their operations. So it's a very simple and easy to understand topic. Okay, so just to give you a bit of warm up. All right, nice. Okay, so I send you a PDF. Involves some questions. Okay, so just to let you know, over here 1.1, that means topic 1.1 is primes and prime factorization. So I was actually asking you this question: what are some examples of prime numbers? Have you learned about this concept before, prime numbers?
I don't have the PDF.
Never mind. So I'm just asking you right now. I think you can see my screen, right? So do you have any idea what are some examples of prime numbers?
Yes.
Okay, so what are prime numbers?
It's the numbers that you cannot times into.
Once again, I didn't catch. The numbers that you cannot times into.
Yes.
Okay. I don't know where you learned this definition from, but it's not quite right. Okay, it's not quite right. So prime numbers. Okay, prime numbers are numbers that is that are divisible by 1 and itself. Okay, let me repeat once again. So prime numbers are numbers that are divisible by 1 and itself. Okay, so now, based on this definition, can I ask you, if is 4 a prime number? Is 4 a prime number?
No,
Why not?
because you can 2 times 2 equals to 4.
Exactly. So 4, in fact, when you are given a number, what you need to do is you need to find out the factors of 4. So for 4, you can 1 times 4, and then you can also use 2 times 2, and then you realize that, so you have this 4 can, okay, so that means basically with this, so 1, 2, 4 are factors of 4, right? So you see that, oh, it's not 1 and itself. You still have 2 in this case. So 4 is not a prime number because you have a 2 as a factor, which can't meet this definition. Okay, so you are right. So let me give you an example of a prime number. So 7. So if you have 7, so if you are asked, is 7 a prime number? I'm going to tell you why you need to learn this prime number.
Yes.
Because, okay, so it is a prime number because 7 is only 1 times 7. Okay, nothing else. Okay, let me answer you further. Can you say 2 times 3.5? Can, right? 2 times 3.5 is also 7, right? Okay, but over here, when we talk about prime number, we don't talk about.
You can only use like whole numbers.
Exactly. So we can only consider whole number. Okay, we cannot consider fraction, we cannot consider decimal number. So that means this is not valid. Okay, so that's why the number one thing when you want to find out whether a number is a prime number, the number one thing is you find out the factors. So the factors can only be 1 and itself. So if the factors are 1 and itself, then it is a prime number. Okay, so 7 is a prime number in this case. Okay, so pretty easy, right? So if you are asked to find out, or you are asked to give some examples of a prime number, what you need to do, you just have to give the numbers that are divisible by 1 and itself. Example 2. So 2 is 1 times 2 only, right? So 1 and itself, right? So 2 is one example. Then now, can I ask you, is 1 a prime number?
Yes.
So the definition is divisible by 1 and itself. So 1 is 1 times 1, right? So you can see it as 1 and itself, right? But over here, please remember that 1 is not a prime number, because for a prime number, you need to at least have 2 factors. Okay, so let me refine this definition. Refine means improve. Let me improve this definition. Okay, so prime numbers are numbers that are divisible by 1 and itself. Okay, and you need to have 2 factors. Okay, so in this case, 1 is not a prime number because it does not have 2 factors, because 1 is equal to 1 times 1, right? So 1 is the only factor of 1. Okay, so it does not it does not meet this requirement, which is 2 factors. Okay, so this is the definition of prime numbers. Okay, so next question, we are going to continue. How to find the prime factorization of a number or several numbers? So I have just shown you how you can find a prime factorization of a number already. So let's do an example. Let me launch PowerPoint. So these days you are in school, but you are learning nothing. I don't understand what do you mean by you learn nothing. So you go school for what?
Movie done.
Pardon?
We watch movie, end of sentence done.
Watch movies. What movie you watch? Okay, so we are talking about prime factorization now. Of a number. Okay, so let me give you an example. 12. Okay, so 12 you can put as 1 times 12, right? Am I right?
Yeah, but this is not the prime number.
This, okay, by the way,
it can be put by 3 times 2 times 6, 3
exactly.
times 4, 4 times
exactly.
3, and more.
Yeah, exactly. So yeah, good that I hear from you. So it's 2 times 6 and then 3 times 4. And then of course, then you repeat itself 3 times 4 in reverse. So we don't need to continue because it's basically you just continue and just reverse the 3 times 4, reverse the 2 times 6, reverse the 1 times 12. So I will stop at here. So what you can do here is 12 is not a prime number. Okay, 12 is not a prime number, but over here the question is asking prime factorization. So I want you to see the difference between prime factorization and prime number. Okay, so in this case 12 is not a prime 12 is not a prime number. That's why you can do prime factorization. That's why you can do prime factorization. Okay, 12 is not a prime number. That's why you can go ahead and do prime factorization. Okay, so let's continue. Next slide. So 12, like you say, 1 is not a prime number. Okay, so I cannot choose 1. I cannot start with 1 because the question wants prime factorization. Prime factorization. So for prime factorization, that means you are going to list down 12 in terms of all its factors. But all these factors have to be prime numbers. That's called prime factorization. Understand? Yeah. So prime factorization means.
So what if you can only make this number out of numbers that are not prime numbers?
Very good. So we have to somehow. Okay, let's look at this example, and you realize all numbers are made up of prime numbers. Okay, you can. So what I'm trying to say is.
So can we put like 3 times 2 times 2?
Very good. So actually, right, if you learn what we have learned just now, the lowest prime number is actually 2. 2 is the smallest.
What about 0?
What about 0? Later I answer you. So 2 is the smallest prime number. You talk about 1. 1 is 1 times 1. So not 2 factors. So cannot. Right? Not 2 factors, right? Okay. So 0. So 0 is what? 0 is 0 times 4. Also can. 0 times 5 also 0. Then 0 times 6 also 0. So can you see you have so many factors? Okay. For prime numbers, what's the definition? 2 factors. 1 and itself, right? This is the definition of prime number. So you look at 0. You have 0 and then 4, 0 and then 5, 0 and then 6. So you have more than 2 factors. So you cannot say 0 is a prime number. Okay, 1 is also not a prime number because it has only 1 factor, not 2 factors. So the smallest prime number is 2. Okay, 2 is the smallest prime number. So in fact, when we learn this concept of prime factorization, right, what we are learning is we want to find out the building blocks of all numbers. So we are talking about 12 here. So for 12, what is the building block? Like you say, the smallest prime number is 2. So let's start with 2. Then after that, you have 2, then you have 2 times 6. But the question I ask you is 6 is not a prime number, right? So you split 6 again, right? You split to 2 and 3. Then you ask yourself, is 3 a prime number or not?
Yes.
So how do you test? 2 factors, right? And then 1
times 3
itself, right? So it's 1 times 3 only. Yes. So 3 is also a prime number. So therefore, if you combine this working into just one single line, you will get 2 times 2 times 3. So this is the prime factorization of 12. So far, so good. And I will teach you why you need to do prime factorization. Okay, it's going to help you in harder questions later on. But at least you know prime number and prime factorization until now. Okay.
Joe, can you go to the? Can you go to when you started explain the what is prime numbers? I need to write down.
Oh, okay. By the way, this video is recorded, so you have no worry. You have no worry about missing anything. Okay. So once again, prime numbers, 2 factors. Can you see here? 2 factors, and then 1 and itself for prime number definition. And for prime factorization, you need to have prime numbers that can help you get 12. That's called prime factorization. Okay, so far so good. So far so good. Can we proceed?
Yes.
Very good. So very easy. Prime numbers, 2 factors, 1 and itself. That's how you decide whether it's a prime number. Prime factorization, prime numbers that can give you 12. So in fact, I'm going to give you 24. So can you show me the prime factorization for 24? You can do it on the screen. Can you type out or not instead of because you're using your MacBook, so you can't write, right? So can you type out the prime factorization of 24? You can do it on a piece of paper also if it's easier for you. Well, you're wearing mask at home. Okay. Okay. So what you can do is you always start with the smallest prime number. Okay. So the smallest prime number is 2. So it's 24. Then you 2 times 12, right? Then in the end, then you split the 12. The smallest prime number is 2, right? So it's 6. Then you continue 6, and then it's 2 times 3, right? Okay. So therefore, the building blocks of this 24 is 2 times 2 times 2 times 3. Okay, so that's why your answer is correct. Okay, just that the order doesn't matter. The order doesn't matter. Okay, so you can write it 2 times 2 times 2 times 3, or you can also write it this way. So both are correct because you put the okay. Of course there is a tradition. It's better to write in ascending order. Okay, so from smallest to the biggest number. Okay, that's easier. All right, that's easier. Okay, instead of descending order, but both are correct. The order is not so important when it comes to prime factorization, because they only ask for prime factorization, right? Prime factorization. They never ask you must arrange in ascending order or descending order. They are focused on prime factorization only. So your answer is correct in this case. But if you get big numbers, then it's going to be a problem. Let me show you. Right now, 24 is equal to this. It's still manageable. What if you get, let me see. Let me use my calculator. Okay, what if you have 588? What are you going to do? Are you going to continue to do this? Like 2 times something, then after that you continue to 2 times something and all this? I think it doesn't make quite, I think it's, okay, it can be done, but not the best way to do it. Okay, because the number is so big. This way of doing things can be done, but not the best way. So I'm going to teach you a easier way to find out. Okay, I'm going to teach you an easier way to find the prime factorization. So a lot of schools, they will teach you this way, like 2 times, then after that continue to 2 times, and then continue to do 2 times. Okay, I don't think this way is the best way. You can, but not recommended. Okay, so I'm going to teach you an easier way. Okay, usually the way to present this kind of solution is you start with 588, right? Then you need to have some ideas what are the first 5 prime numbers. So 2 is the first prime number. The second one is 3. What about the third one? Can you guess the third prime number?
5, and then the fourth
5.
is 7, and then the
okay,
sixth is
the fifth one is
9,
9.
and then
9,
11, and then 13.
9 is 3 times 3.
Oh,
Cannot. 9 is
11.
not. Yeah, so good. So that means you need to first figure out the first 5 prime numbers. So with this 5, then your life is actually much easier. Okay, a lot of people like I say, they will start with 2. Okay, because can you see 8 8 as the 8 can be, okay, when you see 8 right in a number, then generally it can be divisible by 2. It can be, okay, it can be most of the time. So now these are the 5, okay, these are the first 5 prime numbers. So for 588, you can actually divide by 2 first. So when you divide by 2, you get 294. Then after that, you continue to divide by 2, you have 127. Okay, not 127, 147. Right? And then, okay, looks like I run out of space, so it's better that I do it on the right hand side, which is here, or rather next page. So 588, so you just do it this way. 2, you're going to get 294. Then you have 2 again, then you have 1.
I know how to do this.
You learned before?
Yeah.
Nice. Okay, you go ahead. You go ahead, and then finally you tell me what's your answer for prime factorization of 588. So it looks like you have learned a lot of things in advance. I thought you have not learned this.
Like this, right?
Good, very good. So let me continue with this. Yep, I saw your answer. So it's 147.
2 times 3 times 7. 2 times 2
So,
times 3 times 7 times 7.
Very good. So it's 3. So this is 49. And then after that, you have 7 times 7. Then can I ask you one last question? Is 7? I thought you need to continue to do. Do you need to do one more time for
So
7?
because it's already a prime number.
Yeah, so you don't need. All right, because it's a prime number, so you stop. Okay, 49 is not a prime number, that's why you continue 7 and 7. But 7, then you realize 7 is a prime number already. So what I'm trying to say is when you stop, that means when you stop the division. So you stop when you realize that the last number here is a prime number. That's why it's important to remember the first 5 prime numbers. So that means you see at the end, if you get 2 or 3 or 5 or 7 or 11, you see any of them, you stop already. Okay? Okay? Can? Of course, the next one will be 13. The sixth one will be 13. Okay? But of course, I think generally, if you remember the first 5, right? I think you can solve most of the questions already. Okay? And you know when to stop already. Okay? So that's why you reach 7 at the end, then 7 is a prime number. That's why you stop. Very good. So you stop. So once you stop, what you do, you just 2 times 2 times 3 times 7 times 7. So basically you just pick and then multiply them together. So this is the prime factorization of 588. Okay, so let's not stop here. Okay, so can I ask you, if you look at this 2 times 2 times 3 times 7 times 7, right? This prime factorization looks not very complicated, but look not as simple. Okay, so you can in fact do it you can do it better. You can express it. Let's say you have 2 times 2 is actually 2 square. Hello? 2 times 2 is actually 2 square. Then after that,
3 times 7 square.
Correct. So in fact, right, this is also another way. So this is one way to express the prime factorization. Then this is another way to find. Yeah, exactly. You can actually use your calculator to confirm the answer. But my understanding is normally this is paper 1. So paper 1 calculator is not allowed.
This is paper 1.
Yeah, this is paper 1.
Oh
so calculator is not allowed. So when calculator is not allowed, you cannot use your calculator to confirm your answer. But anyway, for me, I think this is still very simple to find prime factorization. Okay, so one way to express it is this: you list all the numbers down. The other way is you can do it this way: 2 to the power of 2 times 3 times 7 to the power of 2. Okay, both ways can be the answer for the prime factorization of 588. So it's really up to you, whichever way you want. All right, okay, very simple. So next question. We have answered 2 questions here already. Some example of prime numbers, 2 factors, 1 in itself. Find prime factorization of a number. Now we want to talk about prime factorization of several numbers. How are you going to do it? Several, not only one, several. So what if I give you 14 and then I also give you 28? So how are you going to do prime factorization? In fact, you just do it individually first. Okay, 7 is a prime number, I stop. 2, 14, and then after 2, 7. Okay, good. So you do it individually first. So 14 is 2 times 7. And then 28 is 2 squared times 7. So from now onwards, I'm going to use the shorthand method to show my prime factorization answer. So this is the prime factorization for 14, and then this is the prime factorization for 28. Okay, so that's how you do it. You do it separately. All right. The next question, more interesting. Why do we need to learn prime factorization? So can you give me some idea why do we need to learn prime factorization?
Because MOE is like that.
In real life, what I mean, okay. In fact, of course, we study mathematics for our exams. Okay, a lot of students study mathematics because they want to score in exams. But what about besides exams? Why do we need to learn prime factorization? Why you want to break down a number? Why you want
Because MOE demands it.
Okay. No, nothing to do with the exam. So do you think there are some real life examples that you make use of this? You need to break the number down to prime numbers. Any real life example?
No,
No.
none that I know of.
Okay. So in fact, I'm going to give you an example and you are going to see that this is quite relevant in our real life without you realizing it. Okay, now let me give you an example. So let's say you have 7 boys. Okay, and then you have 14 girls. Okay, so let's say you have some money. Okay, you want to find out the least. Okay, let's say you want to give a $2 gift. Is $2 better? No. Let's say you want to give the least number of sweets to the students above. Okay, so how do you find the least number of sweets to the least students above? So probably you can do this 1 each, so 7.
But
one each, 14, right?
Yeah.
So you need to buy 21.
It says money there, but then how come it turned into sweets?
You need to use money to buy sweet, ma.
Oh, okay.
Or you just go and ask without paying, right? So I don't want to give you the amount of money first. You have to decide. So the least number of sweet, right, to the student above is, so if 1 each to the boys, you need 7. 1 each to the girls, you need 14. So in fact, 1 each, you need 21 because this 7 plus 14. So you need 21 sweets so that you can give 1 sweet to each of them. Am I right?
Yes.
Okay, then now what if you have a pizza? Okay, you have a pizza. You have 7 boys. And then you have 14 girls. Okay, so for 7 boys, okay, let's assume you don't have the girls, you only have the boys. So how do you cut the pizza? You can cut the pizza to 7 slices, right? So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So you can cut into 7 slices. So it's 1 slice per boy, right? Am I right? So what if you want to have 2 slices per boy? So you are going to cut 14, right?
Yeah.
Yeah. So over here, total is 7 slices. Over here, total is 14. Okay. So if you want to have 3 slices, boys, you're going to cut 21 out, right? Okay, so now, what if I have 5 girls? Okay, what if I have 5 girls? Okay, let me use another slide. Okay, what if I have 5 girls? So 1 each, you're going to have 5 slices. 2 each, you're going to have 10 slices. 3 each, you're going to have 15 slices. 4 each, 20. 5 each, 25, right? So you can start to see what? You can start to see if you have 5 girls, these are the possible slices you can cut out. And then if you have 7 boys, these are the slices you can cut out. And for these 7 boys and 5 girls, right? So you don't see that they have any number that match, because we have not run the numbers far enough. In fact, you can continue to run the number far enough. So 4 each. So you have 28. 5 each, you are going to have 35, right? So for 7 boys, you can cut 35. In fact, for 5 girls, you also can cut. So 6 each, you are going to have what? 30. 7 each, you're going to have 35, right? So can you see that they finally have a common number 35. So this is, imagine you have 7 boys or 5 girls. Okay, in order to, you have the same pizza, but if you want to divide the pizza into 7 boys or 5 girls, right? Okay, the pieces you should cut is 35. Because when you cut this into 35 pieces, you can actually distribute the pizza without any balance. Right? Does it make sense now?
Yeah.
So if you don't cut 35, imagine you just cut, you cut, just now we have a number. So imagine you cut 28, okay? 4 slices each, you cut 28. So if you cut 28, right? For 7 boys is 4 each, no balance. But here you have balance already. Here you can have 5 each, but 3 balance. And then because of this, the 3 balance, you cannot divide equally. So in fact, right, if you can do the prime factorization, you know that you can actually divide something equally. That's the key. Why we want to learn prime factorization. So to learn prime factorization is to divide things equally without balance. We are talking about fair and square in the world, right? Like fair, we must be fair, right? Right? So this is kind of like a way for you to decide, okay, how many pieces should I divide so that I can distribute it equally, given what I have. Does it make sense to you now? Does it make sense to you now?
Yes.
So let's say in your class, how many boys and how many girls?
I don't know.
Okay, let's assume you have 20 boys. Okay, and then you have 18 girls.
Wrong.
Huh?
Wrong.
Assume
I know that there's around 6 more girls than boys.
Okay, never mind. Then I try to change it. 12 boys, 18 girls. Okay, so now I'm going to buy a pizza.
Oh, there's 39 students in our class.
Never mind, let's take it as 30. Easier for our calculation. So I'm going to buy a big pizza. So can you answer me? How many slices I should cut so that I will not waste? Okay, either distribute to boys or distribute to girls. How do you answer this question?
Let me calculate.
So how many slices do I cut to distribute equally? This is all, not n. If it's n, it's very simple. N means 30. 30 means 1 each, 30 pieces. But this is not n. Remember the word here, all, not n. So how many slices do I cut so that I can distribute this pizza equally to 12 boys without balance or 18 girls without balance? Remember the keyword here, or not n. N is very simple, 30. You just add 12 plus 18. So the number one thing you need to do is you need to find out the prime factorization of 12 and 18 first. Can you proceed with 12 and 18 prime factorization first? Then slowly I will lead you to find that magic number.
They both end with 3.
Very good. So over here is 2 times 2 times 3, right? And over here is 2 times 3 times 3, right? Okay, good. So with this, I can actually simplify it a bit. It's 2 to the power of 2 times 3. Over here is what? 2 times 3 to the power of 2, right? So with this, then you can see that, oh, in 12 and 18, what are common? 2 is common, 3 is common, right? Am I right? Am I right? Okay, good. In fact,
Yeah.
in fact, right? In fact, if you don't, okay, like I say, okay, let's okay. This is one way to represent 12's prime factorization. This is another way to represent 12's prime factorization. I usually prefer the second way. Okay, I usually prefer the second way. This is second way. This is not the first way. So we are not going to use this way anymore, okay, to represent the prime factorization. We move on to the second way to represent the prime factorization. So you can see that the common factors, right? The common factors is actually 2 and 3. So in fact, right, you can actually write down, okay, for 12 and 18, 2 and 3 are the common factors. I'm going to lead you to how you can find that magic number, but you need to know 2 and 3 are the common factors. How do you know? Just read from the second way of prime factorization. They both have the 2, they both have the 3, right? So with this understanding, since 2 and 3 are the common factors, then you want to find the number, the magic number that they can distribute equally to 12 or 18 without balance. You do this. I'm going to go to the next slide. 12 is 2 square times 3. 18 is 2 times 3 square. By the way, these two prime factorization is from this slide. From this slide. Okay? So I just copy it over. So therefore, 12 and 18, right? Okay. So we are going to find out the highest common factor. We are going to learn lowest common multiple. And one of these is going to give you that magic number that you can distribute without balance. So let's look at the lowest common multiple first. How do you find the lowest common multiple? You take out the common 2 and 3. And you just read 2 to the power of 2 here, then 3 to the power of 2 here. So for the lowest common multiple, which is here, short form LCF, LCM, I'm sorry. Take the capital letter of each word, so LCM. So the LCM, right? The LCM of these two numbers is 2 times 3. But you need to pick the power, okay? You need to pick the power. So the highest power for 2 between these, so here is 2 to the power 1, by the way. This is also 3 to the power 1, which you never write, but actually it's there. But we don't need to write because it's 1, okay? So you just pick the highest power among these 2 prime factorization. So you realize this is 2 to the power of 2. Among these, right? The highest power for 2 is 2, right? I pick this one, right? Then for 3, the highest power is also 2, right? You compare, the highest power is also 2, so I put it here. So the LCM is actually 2 to the power of 2 times 3 to the power of 2, which is 4 times 4 times 9, so it's 36. So 36 is the number of pieces you cut so that you can give 12 boys without balance, or you can give 18 girls without balance. Let's test. If you cut 36, you give to 12 boys, you have 3 each for boys. If you give it to 18 girls, you have 2 each without balance. You see? Yeah, exactly. So 36 is the magic number. Does it make sense now? So that's why you need to learn the prime factorization and choose the. So basically, this is prime factorization. This step is prime factorization. We have talked about just now, right? And then one more concept is you need to learn LCM, lowest common multiple. How do you get the lowest common multiple? You pick the numbers that they have. Okay, you pick the numbers that they have, and then you pick the power, the highest power that for the number to find the LCM. So once you find the LCM, then that is the magic number that you can have to distribute without balance. Okay. So I think you have no problem with prime factorization. So the only problem you might have is LCM because it's your first encounter. So it usually takes some time for students to understand and make use. So I'm going to give you another example. So now you can actually experiment, or you can actually do it on the spot to test yourself. So let's say just now, how many students you have in your class? Just now you say 39? 39. Okay, so I'm going to do, and the difference is 6, right?
I think so.
Okay, good. So I can actually figure out. Okay, like you are testing me. Okay, let me solve it on the spot. So girls more, right, or boys more?
Girls.
Girls more. Okay, good. So this is the simultaneous equations. Okay, this is simultaneous equation. Let me just solve this simultaneous equation so that I can. So you plus them together is 40. 骗我，不可能。
我不知道 I said around. I said around, right?
Okay, never mind. So you see, it doesn't make sense, huh? You cannot have a decimal number for girls. Okay, so it doesn't make sense to have 39 already. All right. So okay, so that means you see, with the knowledge of mathematics, then you know that these numbers doesn't make sense. So we need to change it a bit. Let's see 38. Can 38 be is valid or not? So if it's 38, then this is 44. Okay, makes sense. 38. So 44, and then you have 22 girls, and then of course with this boys is 16. Okay, this is more reasonable. Okay, so if you have 22 girls and you have 16 boys, so my question to you is not Anna, sorry, once again, not Anna, or 16 boys. Hey, by the way, if it's Anna, it's very simple. If it's Anna, so 22 girls and 16 boys, right? You just add it up, it's 44. not 44, 38. I'm so sorry. So if it's the question is n, right? So the total is 38. Then you just give one each. Huh? No need to think too much already. Just cut it 38. Okay? Very direct, very straightforward. This kind of question is only good for your P2 brother. Okay, but when you reach set 1, they will not.
It's not P2.
Then P3. Going to P3, is it?
Not in P3 at all.
So P2, your brother?
He's so much younger than that.
Oh, so P1.
Yeah.
Your brother is P1, next year P2.
Yeah.
Okay, good. So we are talking about all. So now you have a pizza. So how many pieces you can cut so that you can give 22 girls without balance, or you give 16 boys without balance? So the number one thing to do is 22 prime factorization first, 16 prime factorization first. Then later we go and find out the magic number. Can you figure this out first? I think it's pretty simple. 22 is 2 times 11. 11 is a prime number, so I stop already. 16 is what? 2 times 2 times 2 times 2. Am I right?
I was going to type it.
Oh, never mind. So 2 times.
Delete it again.
Oh, delete? I never delete, right?
No, I have to delete because you already write down.
Oh, by the way, like I say, right, I'm not very, we are not going to use this way of
2 and 4.
Yeah, 2 to the power 4 actually. That's how you read it. Okay, we're not going to use this way to represent the prime factorization, okay? So we just simplify it to 2 to the power 4. 2 to the power 4. Okay, so to find the LCM, so it's called lowest common multiple. Okay, so how do you find the LCM? Okay, to find LCM, very simple. So 22 and 16. Okay, the LCM of, so in fact, right, the question should be like this. It says, what is the LCM of 22 and 16? Okay, so the LCM is, so you just look at this, 2 and 2, right? They both have 2, right? So you write down 2. Then over here, 11 is in 22. 11 is not here. So do you consider 11 or you don't consider 11?
11.
Yeah, I mean, 11 is here, right? But not here, right? There is no 11 for 16, right? So do you consider 11 also inside this LCM?
No.
Actually, you need to, because as long as the number is there, you need to consider. If you don't consider, right, I'm going to show you don't consider. Let's say you don't consider the 11, and then you pick the highest power. So you pick 4, right? You will end up with 16. So 16 is the magic number? No, 16 is not the magic number, because if you cut it to 16, 1 each, right? But for 22, you cannot satisfy the 16, cannot satisfy this 22.
Yeah, you disappeared.
I disappear. Okay, never mind, I'm still around. But anyway, if you choose 16, you can satisfy 16 boy, 1 each. But if you choose 16, you cannot satisfy these 22 girls. Right? So that's the reason why you cannot just take. So what I'm trying to say is, you have the prime factorization already. Then next you look at the prime factors here. The prime factors here, you have 2 and you also have the 11. Okay. So the prime factorization for this 22 and 16, right? You have 2 and 11. And then after that, you go and decide what is the highest power for 2. The highest power for 2 is 4. What is the highest power for 11? 1. So you end up with 2 times 4 is 8, 11, so it's 88. Yes, so 88 is the magic number. Then you can actually calculate. 88, this will be, what's that? 88 divided by 16. Is it 88? No, not 88, sorry. I make a mistake here. 2 to the power of 4 is 16, not 8. You see, that's the problem with mental calculation. So 16 times 11 is actually 176. So 176 is the answer. Can you help me out? Can you help me out a little bit? 2 to the power of 4 is it 16?
Yeah.
Then 11. So 16 times 11.
Wait. Yeah, it's 16.
Then can you help me out this 16 times 11?
176.
176? Is it correct? Okay, good. Then let's come back to this. So 176 divided by 16, the 11 each. Then for this, 176 divided by 22, 8 each. Okay. 176 is the magic number. Okay, so like I say, to find the lowest common multiple, right? Lowest common multiple, you need to write down, you need to pick all the prime numbers in this 2 prime factorization. And then you pick the highest power for that particular prime number. So if I'm going to give you a summary for LCM, is pick all prime numbers. And then second step is pick the highest power. Okay. If you make a mistake, you realize one. Like I say just now you make we experiment, we make a mistake, right? We don't consider 11, right? If we don't consider 11, 16 is the answer, right? Then we put 16 into this, right? And we realize that 16 cannot meet this, right? It can meet this, but it cannot meet this. So with this, then you realize, oh, you make a mistake. Then you realize, oh, you need to consider 11 as well. The prime number, that's why I say pick all prime numbers. And then pick the highest power for that prime number. Okay, that's how you get LCM. That's how you can cut the pizzas so that you satisfy either 22 girls without balance or 16 boys without balance. So does it make sense now?
Yes.
So that's how you can actually use LCM, lowest common multiple, which is the long term, which is the actual meaning. So going forward, I'm going to keep using LCM. I'm not going to use lowest common multiple. I'm going to use LCM. Okay, so before we proceed, we will stop here for a brief break. So we will come back in 5 minutes. All right.
Adios.
Yep. So see you in 5 minutes. Hello, I'm back. Hello, I'm back.
You are still gone.
Okay, hold on. Let me turn on my camera.
It is on, but I only see your virtual background.
Pardon?
I only see your virtual background.
Yeah, I also know that. Let me see. I thought you are supposed to see my this.
Nah, I see nothing.
I'm turning on my camera. Hold on. Turning on my camera. Okay, good. So just now we talked about getting a pizza while the camera is turning on. So we are talking about we are having one pizza, how we can actually divide the pizza equally so that we don't have balance for either group of people. So we make use of the concept of LCM. Okay, so to find the LCM, you just pick all prime numbers, and then you just pick the highest power for that prime number. Okay, so these are the two short key points to find the LCM. Okay, the next concept I'm going to talk about is called HCF, highest common factor. And I'm going to tell you how this highest common factor, capital letter for each word. Then I'm going to tell you how this concept of HCF is relevant in our life. Okay, how this is relevant in our life. Okay, so let's choose two numbers. So 70 and 92. Okay, so let's assume that I have a ribbon of 70, 72 better. Sorry, let me change the number to make life easier for us. 72 and 90. So I have a ribbon of 72 cm. Okay, let me call this a red ribbon. And then I have a blue ribbon of 90 cm. So what I'm going to do is I want to cut them both into equal length of shorter strip. Okay, I want to cut them both into equal length of shorter strip. So what is that length? What is that magic number? So what is that magic number? So you have 72 cm, and then you have this 90 cm. And then you want to cut this 72 into small strips of equal length. I don't know how many. You also want to cut this, so you cut the 72 into all these, okay, small strips of equal length. So you also want to cut the 90 cm into small strips of equal length, and somehow your this strip, right? The length of this strip has to be equal to this length of strip without balance. So what is that? What is that length? So what is the length? What's the length for the smaller strip? So you need to make use of the concept of HCF, highest common factor. Okay, so how do you find highest common factor? So very simple. The first step is always prime factorization, 72, 90. So the prime factorization is very simple. So you can 2 times 2 times 2 times 3 times 3. So let's continue. 2 times 2 to the power of 3, and then 3 to the power of 2. So this is 8 times 9. Yes, 72. So this is the final answer. Next, 2 times 45. And then of course you can do 4 times 9. And then of course you can do 2 times 3, 3 times 2. Is this the answer? So you have, no, this is not the answer. So let me quickly just redo it one more time to do the prime factorization. Or actually 5, I'm sorry. Okay, so it's 2 and 3 to the power of 2 and then 1, 5. Okay, so this is the answer, prime factorization of 90. So first thing, you do the prime factorization first. Okay, so now we need to find the highest common factor. How do we do it? So we just need to, so in this case, highest common factor of 72 and 90, right? Okay, you pick, so you need to pick the prime number that are present in both numbers. So you see a 2 here, you see a 2 here. So that's why you write down the 2 because they are present in both. And then the next, you find that they are both present is 3, right? 3 is present in both, right? So 3 is also one of them. Then when it comes to 5, 5 is present in 19, 5 is not present in 72, so that's why you don't choose 5. All right, you don't choose 5 because we are finding HCF, so we don't choose 5. If you find LCM, you choose 5. Okay, later on, you will actually know whether you need to choose 5 or not choose 5 because the answer will tell you. So for HCF, you just choose 2 and 3. And then you choose the, just now LCM is highest power. In this HCF, we choose the lowest power. So between 3 and 1, I choose 1 because I need to choose the lowest power for HCF. Then for 3, between these two, the lowest power is 2. So therefore, 2 times 9 is 18. So 18 is the HCF for 72 and 90. So therefore, the length for each smaller strip is 18 cm. We can test. If we cut 72 into smaller strip of 18 cm, you are going to have how many pieces? 4 pieces. Right? You're going to have 4 pieces. Okay, which is makes sense. And if you cut 90 into 18 cm, you're going to have how many? 5 pieces. Good. So 18 cm is the answer. Right? So what I'm trying to say is you can do the LCM for this. You can do the LCM for this 72 and 90, and you realize that your LCM is not the answer. So you quickly choose HCF. You understand my point? You know, a lot of students, when they are given a question, they don't know whether they should use HCF or they should use LCM. In fact, you don't need to know. You just need to go ahead and do one, and you realize that whether HCF makes sense or not. If HCF doesn't make sense, then you use LCM. You understand me? It's just like you, okay, wait, I don't know whether this applies to you, but this applies to me. Sometimes I walk into a toilet and I realize it doesn't look like a male toilet to me. So I need to quickly get out. So it's not a male toilet. You understand me or not?
What's wrong with you? Why you got no sign there? Is there no sign? Okay, now I can't hear you.
I think my sorry. I think my camera. Oh yeah. Now it's good. Because my can you hear me now? Hello, can you hear me now? Okay, good. Because just now yes. I think something went off. Okay, good. So this is something like I ever experienced this before. I went into a female toilet, assuming I went into a male toilet, and suddenly I realized there was no urinal. Okay, so I quickly get up. Okay, so things happen. So same thing, if you get the HCF and then you realize that the answer doesn't make sense, then you know that, okay, you should choose LCM for that question. Does it make sense now? So now I'm going to give you a summary how to find HCF and LCM. Okay, so for HCF is common. Common means both have the prime number. So you need to choose the common prime numbers first. So common prime numbers, that's step one. Okay, common prime number. And then number two, you use the lowest power for the prime number. Then for LCM, you choose all prime numbers from the prime factorization. And then, how come I write 2 here? And then you choose the highest power for that prime number. Okay, for this one, I want to caution you because it's a bit counterintuitive, like not very sensible. Hey, over here you are talking about highest common factor. How come you choose the lowest power? Okay, and then similarly, over here you're talking about the lowest common multiple. How come you choose the highest power? Okay, so this is the way it is. This is the way it is. If you somehow lowest common multiple, you choose the lowest power, you know that your answer doesn't make sense. Right?
Yeah.
So how come here is highest common factor, but you choose the lowest power for the prime number? So highest shouldn't I choose the highest power? In fact, the answer to you is no. For highest common factor, you need to choose the lowest power. For lowest common multiple, you need to choose the highest power. It's just the way it is. Okay? It's just the way it is. It's just like, how come girls must have long hair and then boys must keep short hair? It's just the way it is. But of course, these days, 不是呢?
No.
If you are in a school, right? I think for boys, right, your hair cannot be longer than your hair cannot touch beyond. 不是吗?
The boy sitting behind me, the fringe is longer than mine.
Yes, in fact, this is unacceptable.
Can put like this.
Yeah, but it's unacceptable, right? It's unacceptable, right?
Never say anything. I sit in front of the teacher. He sits behind me, so he sits one table in front, one table further from the teacher. So the teacher should be able to see, but never say anything.
Oh, but in fact, those days during the assembly, so basically, the teachers will usually check the length of our hair. So if for boys, if the hair is longer beyond this, the eyebrow, right, then the discipline master will come and cut for us. So you know how ugly it is. If the discipline master, which is not a hairstylist, okay, he comes and cut my hair for me, I cannot take it. It's definitely going to be a bad hairstyle if my discipline master cut hair for me. So or imagine a girl like you, your hairstyle is like my hairstyle now. Okay, so this is something. No, I'm not saying cannot, but imagine you go, okay, now you have this video. So next time when you go and cut your hair, you just show this video, you tell the hairstylist, can you cut my hairstyle like my teacher's hairstyle? I want to see you in my hairstyle once. If you dare to.
Can I go to Halloween shop and then they have that you know how they put on the bolt thing, right?
That one is a wig, which is a fake hair. I'm not talking about fake hair. I'm talking about real one. You go and cut your hairstyle like my hairstyle. I challenge you once if you dare to.
Yes.
Okay. So in fact, remember, for highest common factor, you choose the common prime number and then lowest power. For lowest common multiple, you choose all prime numbers in the prime factorization, and then you choose the highest power. So just remember this thing. All right. So now let's have a question. Give some examples of this. Okay, done already. So how to find? Okay, done already. Why do we need to learn? Done already. The pizza, we use LCM because we know that HCF cannot. And then for the shorter strip, for the strip of equal length, we need to use the HCF. Okay, so that's how these two can be relevant in our real life. And now, of course, we need to go and see some examples. All right, this question. Can you see this question? Oh,
Yes.
by the way, right over here, I think you see a new term. It's called index notation. By the way, this way of representing the prime factorization is called index notation. Okay, so this way of expressing your prime factorization is called index notation. Okay, the normal way is 2 times 2 times, okay, 2 times 2 times 2. I need to have 4 of 2, then 11, you have 6 of them. This is the normal way of showing your prime factorization, which is not preferred, like I said. Okay, so remember, index notation means this way of showing your prime factorization. So don't be alarmed next time when you see this word index notation. Okay, but anyway, the question is this. So find the HCF and LCM for these two numbers. So yeah, so what's the answer? So can you remember, how do you find HCF?
2, 4 equals to 16. Wait, let me get my calculator.
So you just let me know what is HCF and the answer for LCM. I write your answer first, then later I check whether your answer is correct.
Sure.
Yes.
The first number that they did is wrong.
Hold on. Why? It's not wrong. It's just too big. Not wrong. It's just too big.
What
Over
is
here,
this?
your this is okay. Can you come closer? 7 times what? 7 times some 7 times 10 to the power 13. Okay, good. Yeah, good. Okay, you need to show me. Okay. So in fact, you key this. Basically, you key this first number to your calculator, right? Your calculator has not enough power to show this answer to you. That's why they use that. That's why you see 7.0 times 10 to the power 13.
And the second number actually makes sense.
Actually, the second number also, okay. You cannot say this number doesn't make sense. This number shows that the number is just too large. Too large is still a number, right? Too large is still a number. So why you always think that a number like this, let's say you have a number like this. How come this number is, okay, this number makes sense, but this number doesn't make sense? You shouldn't think of it like this. Like, you shouldn't be so biased. It's just like, let's say a boy with long hair, and then you say, okay, it's not normal. Okay, what I'm trying to say is, when they give you a number like this, right, it just shows that this number is too large. Okay, imagine, right, you have a number. So if I'm not wrong, right, your calculator can only display a 9-digit number. Anything beyond 9 digit, your calculator is not powerful enough to display. You can key in. Can you help me key in? Can you help me key into your calculator now? Okay, 1 million times 1 million. So 1 with 6 zeros
How many
times
zeros
1.
does the how
1
many
million
zeros
is
does
6.
one?
1 million is 6 zero. So 1 million times 1 million. Then your calculator will show you something like the first one here. Can you show me also? 1 million times 1 million. What your calculator show you? You see
This
1 times 10 to the power 12. Can you see? Something like this one already. Like the 7 point times 10 to the power 30.
1 times 10 to 12.
Yep. So you cannot say 1 times 10 to 12 is not sensible, right? Okay. They are using this. This is called index notation. So your calculator is using index notation to show you the answer only. It just shows it's just too large. This number is still within the capability of your calculator to show it normally to you. Because how many digit is the second number, by the way? The second number here. How many digit? Can you key in again and tell me how many digit for the second number?
One, two, three, 5, 7, 8, 9.
Yeah, so it's still within the capability. Like I say, your calculator can display 9 digits. Okay, so with this tool, right, that's why if you have numbers of this massive magnitude, meaning like so large, right? So the more you need to make use of this summary. Okay, if you don't use this summary to find the HCF or LCM, right, there's no way you can find HCF and LCM for large numbers like this. Okay, so how do you do it? What's the HCF for this question? You don't need your calculator, by the way. You just need to follow the summary on this page. So HCF, right? So what you need to do? You need to find the common prime numbers first. Yeah. So what? Okay. So that means you need to focus here. So between these two factorization, which are the common prime numbers between these two? 2 is them. Okay, 2 is one of them. 11 also one of them. Right? So you write down 2 and 11. So 2 and 11. And then can I ask you? So 2 and 11, they are both there. So you choose for HCF, we are talking about HCF. You choose the lowest power or highest power?
Lowest.
Yes. So 4 and 2, lowest is 2. 6 and 3, 3 is the lowest. So this is the HCF. Then you can use your calculator, 2 to the power of 2 times 11 to the power of 3. Then you can actually write down the answer already. Oh, but over here they say give your
5,
answer
3, 2, 4.
So it's 4 times, I don't know what, but anyway, use your calculator, you can figure it out. Okay, but remember, over here, the question asks you to give your answer in index notation. So therefore, you just leave it like this. You don't have to find out the actual answer because they want you to express it in index notation. So for LCM, so what is the summary for LCM? So for LCM is, let's look at that. Oh, you need to memorize all prime numbers. So you need to choose all prime numbers in the prime factorization. Okay. So 2 is inside, 11 is inside, 19 is inside, 2 is inside. So you just write 1. 11 is inside, 17. So basically you have 2 times 11 times 17 and 19. So I have picked all the prime numbers inside already. So 11 appeared 2 times, I just once. So that's why I pick all the prime numbers present in the prime factorization first. Then now, you choose the highest power or lowest power for LCM.
Highest.
Yes, highest. So 4 and 2, I choose 4. 6 and 3, I choose 6. 17 only one of them, so I just choose 4. 19, one of them, I choose 5. Yes, so this is the lowest common multiple. Okay, I think if you key this into your calculator is going to show you something times 10 to the power of something, if I'm not wrong. You can test because it's too large. Yeah, too large, right? 10 to the power of 16. Yeah, okay, good. So very simple. If you just memorize this summary slide to find HCF and to find LCM. All right, simple, right? Next. So you see this one. So how do you find the values of X, Y, Z? So I leave this question to you. Go ahead. You can use a piece of paper, write your answer on a piece of paper, and then after that, I will help you verify your answer.
So 3, 1.
3, 1.
All right. X is 1.
X is 1.
X is 1. Y is 1. And Z is 2.
Cannot be what? If you 3 to the power 1 times 5 to the power 1, then 7 to the power 2, your this one is what? 3, 5. So this is 15. And then 15 times. So 15 times 49. Let me double check. Maybe, I don't know. 15 times 49. No, leh.
No.
735 only, leh.
But then I do like this.
Okay, good. So let me just do it. Let me see. Yeah, you do it the way it should be. But let's see whether you are correct or not. Okay, so the way to do it is 2205. It's 2205, not 220. So you just, okay, so you give it a 3. You give it a 3 first or you give it a 7 first?
I put a 5.
Okay, in fact, right, a 5 also can. Let's do it with a 5 first. Why 5? Because you see that there is a 5 here, right? So I think you know that if you divide it by 5, then it's divisible. So it's 4, 0. No, not 4, 0. It's 4, 5.
4, 1.
4, 5, 1, right?
4, 4, 1.
Or 4, 4, 1. Sorry, 4, 4, 1. So 4, 4, 1. Then after that, you put a 3.
I put a 7.
Or you put a 7. So it'll be 6, 3, right? Then
3.
After that,
3.
Then it should be 21, ma.
Yeah.
Then 21, you stop.
No, 21, and then I continue with a 7.
3 and then 7.
No,
right?
I continue with a 7.
Oh, you continue with 7. Okay, never mind. You put a 7. And then you end up with a 3.
3.
So 3 is the prime number, right? So then with all these, right? So how many 3 you have? 1 and 2. So you should put a 2 for X, ma, right?
Oh.
Am I right? How many 5 you have? 1 of them.
1.
Correct. Then 7, you have 2 of them. Oh, okay, good. So your Y and Z is correct, but your X is wrong. Okay? So in fact, X should be 2, right? Because you have 2, 3, right? Or in fact, you could have done this. So once you have all these, right, you just arrange them first. Arrange it in a nicely manner. or you have 1, 5 only, I'm sorry. And then you have 2, 7. So once you arrange it in this way, then you know that, oh, I have 2, 3, then I have 2 7s. Then you just 2, then you put it here, 1, you put it here, then 2, you put it here. Okay, so that's how you can actually get the answer. Okay, Ken? Yeah, next. Very simple. So this one, 5A. Can you help me out with 5A first? Yep, please. Do it on a piece of paper. Let me go and grab a drink. Bây giờ dùng là cũng thấy gì đó. Ồ, hay quá chứ. Dạ ạ. Dạ, cảm ơn. All right, I'm back. Okay, so let's check. So x is 4, so that means it's 16. Let me have you double check. 16 times 9 times 11. Yeah, correct. So your first answer is correct. Then written as a product of its prime number is this. Okay, so part B. So in order to do part B, right? In fact, okay, this one is the prime factorization of this. This one is the prime factorization of this. But now they ask for the smallest positive integer, k, such that this divided by k is a square number. Some more? Integer. Okay, good. So just to give you an overview where we are right now, let's go to the syllabus. So let's see how much we have covered today. Can you erase your answer first? 2 to the power 4 times 3 to the power 2. Can you erase this first? Okay, so today we have done primes and prime factorization. And then we have also done this HCF, LCM. Do you know what's the meaning of squares? So 2 to the power 2, this is called 2 squared.
Times something.
Yeah, so square means...
it must be the same number.
Yes, so square means this is called 2 squared. 2 squared. What are you drinking, by the way? Looks good.
Water.
Okay, good. 2 to the power of 2 is called 2 squared. Okay. 3 to the power of 2 is called 3 squared. Okay, so this is called squares. You know what's cubes? Instead of 2 to the power of 2, so it's 2 to the power of 3. So this is, no, for cubes is 2 to the power of 3. Then 3 to the power of 3. 4 to the power of 3. That means the power is 3, that's called cube. The power is 2 is square. Does it make sense?
Okay.
Yeah. Then what is square root? Any idea what is square root?
Is
this one, no? Yeah, this one. Yes. Then what is cube root? Then this one, no? This is called square root.
Beside that thing is like a 3.
Yeah. So
right?
this is square root.
Oh, yeah.
This is called square root. Yeah.
Is that right?
Thanks. Yes, correct. Then this is called cube root. Okay.
What is it called? Root.
No, it's just a name. It's just a name. Just like your name,
Nothing
your,
like the root.
just a name. Oh, nothing to do with the plant root. Nothing to do with the roots of the plant. Okay. Okay. So, so basically we have covered 1.1. We have covered 1.2. Now is 1.3. So
No.
we are talking about negative numbers, integers, and all this. Okay. So let's do it. Which I'm going to cover also. Square root done. Cube root done. Square root is this. With a 2. Cube root is this. Okay. Okay. Some examples of negative numbers. What is negative numbers? That means any
the
number.
minus something.
Yeah, with a minus sign. So my minus 1, minus 1.1,
minus 1,120.
minus 2/3, minus 1,000, right? So all these are example of negative numbers. As long as you have a negative sign, it's a negative numbers. Okay, this is also one of them. Yeah. Okay, very easy. Negative numbers. What are some example of integers? You know what's the meaning of integers?
No.
Serious? You don't know what is integer? Okay, good. So integer is, okay, for integer, you have negative integer. You can also have 0. You can also have positive integer. So if you are going to use a tree branch, I believe for what? So let's say if you want to branch out for integers, right? So you have negative integers. I use int, and then you have 0, and then you have positive integer. So of course, now you're asking me, what is negative integer? How is negative integer different from negative number? Right? You know what's integer? Integer means it must be, 什么？
我不知道。
Oh, okay. Integer must be whole number. Meaning it must be 1, 2, 3, 4. It cannot be 4.33222222222. It cannot be 4.2. It cannot be 1/4. Cannot. Integer must be whole number. Okay. Whole number means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all those.
Can it be 3.141592654 something 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 something?
I already say 4.2 is not integer. How can 3 is an integer? Integer must be whole number. Okay, so
did you realize that I just said the number?
Yeah lah, pi number lah. Pi. I'm sorry, pi. We are talking about the value of pi, right? Actually, this is not the exact value for pi because, like I say, your calculator can only give you
it's infinite. It's infinite.
Yes, nice. Yeah, so that's why I say the capability of your calculator is limited, 9 digit only. Okay, so just now if you see, right, negative numbers, you can have negative 1, you can have negative 1/1, you can have negative 2/3, you can have negative 1,000. But for negative integer, you cannot have fraction, you cannot have decimal. Okay, so this is called negative whole number. Okay, then 0, very straightforward. 0 is 0. Then for this is positive whole number. So that gives you the definition of integer. So far so good?
Yeah.
So this one done. Rational numbers. Wow. You know what is rational? What's the meaning of rational in English? Okay, rational means not only calm, rational means logical. Logical means you think logically. You think rationally, not emotional. Like you, let's say you face let's say now, okay, you are doing irrational things because I think you are picking up a knife and you try to stab somebody. That's what I see from your camera. Okay? So you are not doing rational stuff. The most rational thing you should do right now is listen. Okay? So rational numbers in this context. Okay, so I just explained to you what is integer. Integer is you have negative integer, negative whole number, 0, positive integer, positive whole number. They are called integer. So for rational number, let me go to the PowerPoint. For rational number, by the way, for all this definition, you can actually go and Google. Okay, so let's test it out. What is rational number? You see?
Rational number is in mathematics a ratio. A rational number is a number that can be expressed as the quotient or fraction PQ of two integers, a numerator P, and what the hell?
So you see, okay, a rational number is a number that can be expressed as the quotient. Quotient means this. It's a fraction. Fraction of two integers. So fraction of two integers. So what integers? -1. Hello. Can you? Yeah. So -1 is a negative integer. 2 is a integer as well, but it's a positive integer. So this is a rational number. The example they give is -3/7. Okay. So rational number is a fraction that in this form. So basically you have x over y. X can be any integer, and then y can be any integer. So that is a rational number. All right. So I don't want you to okay. In fact, this kind of question, right, is a 1-mark question. All right. Generally, it's a 1-mark question. Okay. And must remember it, non-zero non-zero denominator. Non-zero denominator. Why? Because you know, right, in a fraction, right, even though 0 is an integer, but you cannot have 8 divided by 0 because 0 cannot be the denominator for a fraction. So that's why this case is out. You know, right? You cannot use 8 divided by 0, right? You also cannot divide. Basically, you cannot divide by 0. So that's why please bear in mind this non-zero denominator. Okay? Can? You cannot divide by a 0, right? So this is rational number. Last one. Last one is real number. What's real number? By the way, real numbers is any numbers you learn so far is called real numbers. Okay? Okay, of course, then you must be thinking, what are unreal numbers? Right? Unreal numbers is out of your scope already. So unreal numbers, let me give you an example. This is unreal number, 2i. These are unreal numbers. This is not, okay, this is not algebra. This is not algebra. Don't think of this as algebra. This is not algebra. 2i is not algebra. Okay? 2i is an imaginary number, which is unreal. But of course, this is already out of the scope of your syllabus for Set 1. Okay? We will go ahead and then talk about all this. Okay? In fact, the number 3 point that is only one pi, you know, the simple pi, right, represent 3.1415, you know, indefinite, right? Actually, there is another symbol which is also have an indefinite number. Can you guess what is that? You go and look at your calculator. There is a number called exponential. This is not E, it's not called, okay, you can call it E, but in fact it's called exponential. Exponential. Can you find the letter? Can you tell me the value of E? It's 2. Yeah, to the power 1. It's actually 2 point something.
The answer is syntax error.
No leh. Cannot be leh. E to the power 1 leh.
I show you.
Did you key in the 1 to the power?
Never mind. It's 2.71822818.
Indefinite, right?
Don't know.
Yeah. Is it indefinite? Meaning
I think so.
Yeah, because your calculator can only express 9 digits. Can only display 9 digits. That's why it stopped at the ninth digit. So E is another symbol like pi. Okay. So I'm just trying to expand your this knowledge horizon. I'm just trying to expand your this horizon so that your knowledge is not so narrow, and you know that in this universe of mathematics, right, there are a lot of possibilities, okay, which we have not touched upon only. Doesn't mean it doesn't exist. All right. So as of now, you don't have to know 2i. 2i is not algebra. Okay, it's a imaginary number, unreal number, which you don't have to know. Okay, so with the understanding of so basically what you need to learn and remember is negative numbers, integers, and then rational numbers. This one, real numbers, all numbers you learn so far is real numbers. All right. Unreal numbers you have not learned, and your calculator cannot. Your calculator can. I'm not sure if your calculator can display. But as of now, you don't need to know unreal numbers. All right. Then with this, then we can actually look at the question just now. Over here, it says a positive integer k. So just now, integer, right? Integer, you have negative integer, and then you have 0, you have positive integer. So that means you need to give a positive integer such that this one is a square number. You know what's a square number?
Yes.
Square number means something
times the same
something. Correct. So that means what you need to do is you need to find out 1350 divide by this something. You can square root and you can get a whole number. Okay. So what is the question mark that you can divide so that you get a whole number? And that number must be smaller. So how you do this question? So what you need to do is...
Let me try.
Okay, you can try. Yeah, 1350 is already given as a prime factorization of this. So instead of 1350, I just do it this way. Then you divide by a question mark so that you can square root. Yeah. So how?
I found the answer.
What's the answer?
Wait, K, right? It's 6. It's 6.
Okay.
It's 6.
Okay, I don't know how you test, but actually I can. So question mark is 6. Okay, let me teach you how you can find this k, which you can square root. So I want you to know one thing. I want you to know one thing. So this one thing is something square, right? Versus square root of something. They are opposite of each other. Okay, so that means if you square something, you go and square root this thing, you cancel the square. That means the square root, okay. What I'm trying to say is the square root here will cancel your square. Okay, the square root will cancel your square. The square root will cancel your square. So given this understanding, right, the square root will cancel the square. So that means you will get 2 here. So the same thing, cube root will cancel the cube. So the cube root here will cancel the cube. So you end up with 3. So based on this understanding, right, just now the question is 2 times 3 to the power of 2 times 5. Let me see. 5 to the power of 2. Yeah. So this is 1350, right? 1350, the prime factorization is this. So they ask 1350 divided by k. So you need to square root it. So what this means is you just have to, okay, first you express the 1350 in terms of the prime factorization first. Then you read, is it 3 to the power of 2? Let me double check. Oh, 3 to the power of 3, I'm sorry. Can you see? 3, not 2. So it's 3. So it's 3. So what you need to do is you just need to see which number here can be cancelled. So square root can cancel the 2, so you don't need to do anything. Can you see? The square root can cancel the square, right? Then you don't do anything, because it can be squared. I mean, they cancel each other. Square root and square, they cancel each other. So I don't need to do anything to the 5 in the sense. Square root can cancel the square, so I don't need to do anything to 5. But here, can you see square root and cube? Can you see square root and cube? So square root and cube, you cannot cancel, right? Square root and something cube. They cannot cancel each other, right? So you must do something to it. So square root can only cancel square. So you need to put a 3 down here. You need to put a 3 down here so that this will become a 2. You understand? You understand or not?
Yes.
So because square root cannot cancel the cube, so you need to have a 3 here so that this, after you have the 3 below, so this 3 to the power of 3 becomes what? Becomes 3 to the power of 2. So that square root can cancel the 2 or the square. So that's why you need a 3 below. So for 2, right? Square root square root cannot cancel the 1, right? So that means you also need to get rid of the 2. That's why you put a 2 below. That's why you get the k equals to 6. Okay, so if I give you another example, so let's say I have 2 to the power of 4 times 3 to the power of 3 and then 5 to the power of 6. No, 5, I'm sorry. So you need to divide by a smallest k such that you can keep root. So how do you do it? So you just ask yourself, cube root can cancel with cube, so I don't need to touch the 3. So the 3 is no need to touch. So I don't need to do anything to the 3. But looks like my cube root cannot cancel the 2 to the power of 4, the 4. So I need to have a 2 below, so that I have a 2 to the power of 3 later on. Then the cube root here can cancel with the 3. Right? Does it make sense? So you need to have a 2 below. Does it make sense now?
Yes.
So you need to have a 2 below. Now, 5 to the power of 5. Cube root cannot cancel the 5. So you need to, how? So you need to have how many 5? You need to have 2 5. 2 5. No, 5 to the power of 2 is actually 25.
25.
Yes. So why you need to have 2 5? Because
times 2.
Yeah. So you know why you need to have 2 5? Because you need to have 5 to the power of 3. Then your cube root can cancel your cube. So you need to have 2 5s below. So if given this, then the smallest k is actually this one, which is 2 times 25, which is 50. Then you can cube root this thing. So this is the way to understand this question. Okay, but today I want you to focus on these two things. Number one, prime factorization. Of course, prime number first. So what is prime numbers? 2 factors. 1 and itself. Okay, that's the definition of prime numbers. And then of course, with prime number, then you know prime factorization. Okay, so one example of prime factorization is 12. So it's 2 to the power of 2 and then times 3. Okay, so this is the prime factorization of 12. Right? Okay. Then with prime factorization, then you can actually find out the HCF, highest common factor, and LCM. And like I say, if you use HCF and you don't think that the answer is correct, then you use LCM. All right? Okay? And of course, for HCF, you use common prime. And then you choose the lowest power for the prime. Okay? Then for this lowest common factor, lowest common multiple, you choose all primes. From the prime factorization, then you choose the highest power for the above. Okay, so this is a short summary for today. So what's the word?
Yes.
Good. So with this, actually we have completed this 1.1, 1.2, and of course 1.3, talking about some definition of some numbers. So what are all these numbers? Okay, then when are you going to go to set 1?
January 2nd.
Okay, which is okay, let's assume that this is November, so you have 11 to December. Wow, you have 2 months.
Yeah.
Wow, a lot of time. Okay, never mind. So we can actually start some of the topics in set 1. So when you reach set 1, then you will feel more comfortable.
Adios.
Any other question?
No.
Any other question? If not, then I will go back and then I will consolidate some questions. Then I will send it to you.
Adios.
Okay. So see you. Okay. Bye bye.
Bye bye.